Before I begin, I want to tell everybody I have a lot of love for the Ruby community, and I want to say thanks to a few people first. First off, I want to say thanks to John. He's been doing a lot of good work on active record relation codes, so you should all tweet at him and say thank you. The next person I want to say thank you to is, well, not really thank you, I just want to show him some love here, is It doesn't look like love. This is a picture of Michael Feathers, and he told me that he put my picture in one of his presentations. So I told him, all right, I'm going to put a picture of you in one of my presentations. So I am going to give him a kiss. So thank you, Michael Feathers. The next thing I want to say is, I also love Jose Valim a lot. I tried to kiss him the other night, and he was not too excited about it. So this talk is called Double Dream Hands So Intense. What does it mean? I don't know. Hopefully you'll find out. Anyway, so now I'm beginning. Now you can start the clock at 45. All right. Oh my God. Happy RailsConf. Welcome. In case you got lost, you don't know where you are, my name is Aaron Patterson. You can find me on the internet as Tenderlove. I work for a giant corporation called AT&T. I know most of you here are probably working for startups. I am an open source developer at AT&T, so what I do there is I work on the tools that we use in order to improve the developers and hopefully improve our bottom line. I actually enjoy working for a giant corporation, and I want to tell you why. Like, there's some things about it that make me extremely excited, and the thing that I'm going to explain to you today is how I file expense reports. So it's actually a really awesome process. This is amazing technology. The way that it works is I have to VPN in. So I VPN into our thing. I work from home full time. So I VPN into our network, and then I have to like fill out a form and click on all the things that I spent money on, and then I have to fax my receipts. Like it gives me a cover page, and then I have to fax that in with a bunch of receipts. And then on the other end of the fax machine, it like scans it in as a PDF, right? So so once it's scanned in as a PDF, like then I can see that and verify my receipts, and I'm like good to go, right? I submit the expense report. But it's kind of a pain because I work from home, so I don't really have a fax machine. So I keep spending like $2 or whatever on the little like upload a PDF and it'll fax it off for you. So since I work at a giant company, I went into the we have a phone tool, and I went in and found like the accounts payable person, and I emailed her and I said, hey, how do I work from home, I don't have a fax machine, how do I get receipts to you? Like, I don't, what do I do? And she says, okay, just, put everything together in a PDF and then email it off to this email address, and you'll be good to go. So I'm like, okay, great. Next time I had to file an expense report, I sent an email to this email address. About 3 minutes later, I get a response saying, fax sent. So I emailed an email address to send a fax. I emailed a PDF to a mail to fax thing so that it gets faxed to a place to get scanned back in as a PDF. This technology, it's amazing. So anyway, I will continue. That is why I enjoy working at a giant company. I get very nervous up on stage, and Jose told me one thing that you need to do while you're up on stage is just ask yourself, what would Freddie Mercury do? So I always include this in my presentations to get myself, less nervous. And then even worse is that I'm delivering a keynote, and I went and looked at all the other keynote speakers, and we have people like Dick Gabriel and Guy Steele, DHH. These people like changed the world. They changed the world of computer science. They changed the world of business. I mean, more CTOs. We have CTOs that are keynoting. Dr. Nick, he's a freaking doctor, right? Corey Haines. Corey Haines is so awesome that his title is his name. Like, that is amazing. It's amazing. I'm so jealous. We have an adventure advisor. I don't know what that is. I am merely a senior software engineer. How can I be up here? It doesn't make sense. So I'm worrying about this, and all of a sudden I get an email or a IM from Chad. He says, hey, do you want to hear a story about sex in the tech industry? And I was like, okay, sure. He's like, well, you know that email that O'Reilly sent out about RailsConf? This is the email here. Well, there's click tracking on all of the pictures of the keynote speakers. And your head was clicked, like, by far and away, clicked more than anybody else. So I just want to show you guys, like, what you clicked on. Like, what is wrong with you? Why did you click on me? So anyway, thinking about this, like, what is it that can separate me from the other keynote speakers is I know about Ruby and I know about Rails. I am the only person on the Ruby core team and on the Rails core team. And the other thing that lets me stand out from the other keynote speakers is that I look ridiculous. So with that in mind, we have 3 items on our agenda. I'm going to talk about new features in Rails 3.1. I'm going to have a little bit of real talk, and then we're going to look at some development pro tips. And I have to warn you that this talk will be very technical. This will be a very technical talk, so prepare yourself. This will also be a very critical talk. I'm going to be critical of our framework. And I want to take a minute here to say, there's a difference between being critical and like being a hater. So I'm going to say some bad things, but I'm going to talk about how we're looking to improve them and how we'll make our awesome framework even more awesome. So on with the new features. We're going to look at the stuff that's been added to Rails 3.1 over the past year or so. And before we get into that, I want to talk a little bit about my strategy for modifying APIs. My particular strategy and just the way I like to modify APIs is to either not change them, so hopefully implement exactly the same interface that you're using today, but give you speed improvements and just better features with them, or extend them so that you can make them better, but use better features, but always make sure that they're backwards compatible. So that's my strategy, and we're going to look at some of the features that incorporate that, but we're also going to contrast them against some of the features that are added in Rails 3.1 that don't follow that particular strategy. The first thing I want to look at, though, is we got a bunch of new generators in Rails. And since I can't see anybody here, I'm not going to ask for a show of hands. I will just assume all of you work for startup companies. Well, probably 90%. The new generator that we included is Rails Generate VC. So when you're running out of money, you just run this thing. Boom, money. Apparently, it only works in San Francisco. The other thing that DHH just committed this the other day, it's called halts ? You give it a function, and it tells you whether or not that function finishes. It's pretty amazing. I have to say, this has changed the face of computer science. But really, we're going to look at prepared statements. I added to Rails 3.1 prepared statement caching support. And what that is typically we send a SQL statement to our database that looks like this, but Instead, now we're going to start sending statements that look like this. So we'll put in placeholders for the values that we actually want to use. Oh my God, I only have 37 minutes. So normally we have a Rails application, we generate a SQL statement, send it off to the database, we get records back, and we just keep doing that over and over and over again in our application. In the new world, what we're going to be doing, that takes 4 steps on the database side. The database has to parse our SQL statement, then it has to come up with a query plan, then it has to execute that query plan, and finally it has to return results to us. Right? So in the new world, what we're going to do is we're going to send a statement off to the database and say, hey, I'm going to execute this in the future. I don't know what the values are going to be in the future, but I'm going to execute a statement like this. And the database says, OK, great, passes you back a token. And what the database does is it parses the SQL statement, and it comes up with a query plan and then caches that. Right? Then when we want to make subsequent queries to the database, we pass along that token along with the actual value that we want to put into the SQL statement. And then the database returns the records to us. So these 4 steps become 2. So we only have to prepare this statement once, and we keep that token and keep reusing it over and over again. And in subsequent times to the database, the database only has to execute the query plan and return results to us. So it's typically faster. And I want to share with you the impact on the 3 different database adapters that we have: SQLite, Postgres, and MySQL. With SQLite, the performance looked a little bit like this. It's linear performance. I just like to show linear performance graphs to make sure that I didn't fuck anything up. So really what we want to look at is the number of queries per second we were able to perform. So on average, before I implemented prepared statement caching, we could execute about 8,600 queries per second. After implementing statement caching, we're doing almost 1,300 queries per second. And this is on a simple statement. So if we say like the most simple statement you could possibly say, select star from wherever where ID equals something. And what I wanted to do is increase the complexity of the SQL statement and benchmark that. So I could look at how the performance changed as our queries became more complex. And, so we have a delta here of 4,300 queries per second, to the good. Now, if we try a more complex SQL statement, we're still getting linear performance, but you can see that a much larger delta between the two. We went from 339 queries per second up to a little over 4,000. So very good improvements as far as SQLite is concerned. PostgreSQL, still linear performance. Thank God I didn't screw anything up. We improved from 4,600 up to 5,500 queries per second. So I'm very happy with those results. And as we increase the complexity for statements on Postgres, it still remains, we get even better performance. So this makes me happy. MySQL, the picture is not so awesome. So we remain linear, but if we look at the number of queries per second that we're actually performing, it degraded. And theoretically, when you talk about the amount of work that we had to do, like I explained to you, we had 4 steps. We were able to reduce those to 2 back over on the database. You'd think all databases will go faster. But it's actually not true with MySQL, and I'll talk about why in a minute. So it went down. But as we increased the SQL complexity, we actually improved results. OK? So why is this? Why did MySQL get slower? And the reason is because when you send that prepared statement up to MySQL, it does no query planning at all. It doesn't do any query planning in advance. So it doesn't actually perform the planning until you actually execute the statement. And for some reason, the MySQL API, when you do a normal, simple query, it takes a different code path than when you do a prepared statement. Right? They're 2 completely different code paths. And when you do a prepared statement, it actually requires 2 network round trips. So on MySQL, the only time you're actually saving is SQL parse time. Right? So you have to judge whether the amount of time that it takes to parse that SQL statement will overcome the amount of time for the 2 network round trips. So doing the performance profiling on MySQL is a little bit more difficult. Another interesting thing is that when we use the prepared statement API, we get parsed dates back, pre-parsed dates. So the benchmarks that I'm showing you aren't taking into account any of these return values. We actually get casted values back from MySQL. So when I ask for an integer, it actually gives you back a C integer. And when you ask for a date, it gives you back a struct that contains all of the date parts. But this is only for the prepared statement API. With the normal querying API, you just get strings back. And we have to pay parse time costs for that. So unfortunately, it's very difficult to say whether prepared statements are slow or not for MySQL. So how do we use this in Rails? What are the API changes required in order to use prepared statements in Rails? Before, we would say, oh, user.find1, we want to find our user with a particular ID. And the API changes that I made to enable prepared statement caching on Rails, the front-end API looks like this. Exactly the same. So you get speed improvements for free. Yay. The next thing I want to look at is serialized attributes. Serialized attributes, it looks like this. I don't know if any of you have used this before, but basically what it does is you are able to save arbitrary Ruby data structures into the database. So you can say, like, oh, I want to save this hash of stuff, like maybe somebody's preferences or something. You can save that into the database. And it saves it as YAML. So you say, like, oh, assign this hash, save it off, saves to the database as a YAML. And I was looking at this, working on an application, and I was like, why YAML? Like, why do we save this as YAML and not as, like, JSON or something else? So I started looking in the Rails source and found that the reason we were saving as YAML was because Active Record was very tightly coupled to YAML. We were specifically saying, OK, we're going to go dump this out as YAML in the code. So what I decided to do is just refactor that such that YAML was not coupled to Active Record. And now we can actually configure the storage strategies with whatever storage strategy we want. And it looks like this. We're able to supply a second parameter to serialize with the strategy that we want to use to emit to the database, right? So we have to implement a coder. And that coder encodes our data to the database. And what does that API look like? You just have to implement a load and a dump. Provide that to serialize. On load, that's when you get data back from the database. When you're dumping, that's when you're dumping data to the database. So it's very easy. We can implement base64 storage, JSON storage, Marshal storage, XML storage, right? Everyone wants to store XML in their database. Yeah, love that. Who else is on Oracle? Yeah, I see all those hands with these bright lights. Oh, I want to announce official NoSQL support in Rails. Everybody is excited about that? I forgot to mention that some of the things I say on stage might not be true. But I guess I should probably show it off here. We'll create 26 users with preference hashes. Right? We're going to store unstructured data in our database. Create a bunch of users with preference hashes. And then what we're going to do is we're going to pull this data back out and modify it. So we have our 26 users. What did I do next? I forgot. We find a user and we get preferences back, and we can update these preferences, modify them, and then save it back to the database. But what we're going to do in Rails is we're going to find by somebody's preferences. Yes. We'll see who has their favorite color set to green. I'm the only one that has my favorite color set to green in the database, so hopefully we'll only get one record back. And yes, unstructured data stored in the database, and we can query on it. Yes. Unfortunately, there are a couple fairly important caveats. The important caveats are, it only works on Postgres. And the other important caveat is you might hurt yourself using this. So if you want the code to actually do this, here it is right here. Quickly write it down. No. I will provide the slides on my Twitters, or O'Reilly will provide them too, and you can get this code. But don't use this code. You might notice that there is an eval like right in the middle there. You probably don't want to do that. But it can be done. So another interesting thing about this serialization strategy API is that we can think of other things besides like Marshal and XML and YAML and all those things. We can think about other things as serialization strategies. One of those things that we can think about is encryption, right? So we can implement a coder that saves something encrypted to the database. We can use BCrypt or we can use whatever, but we're allowed to configure it with whatever coder that we want to use, okay? So this particular coder will encrypt our passwords to the database, and we can use it and say, oh, some crazy call. We store our password, like I suck at spelling, and I changed our password column to password with one S, but I'm too lazy to change it because, you know, it takes forever at a giant company. And I have to fax stuff. But now I just email it, which that faxes it for me. Huge productivity improvement, really. But we can configure things and save stuff to the database encrypted like this. So it's not just for two-way bidirectional data saving. And while I was thinking about this API, one thing that was very important to me was, you know, looking at the APIs of different things that dump data. In the standard library, we have YAML, JSON, and Marshal, and their API for dumping and loading data is very consistent. So I wanted to maintain this consistency because my eventual goal would be that you could say, you know, serialize foo and then just pass in the YAML constant. I think that would be very awesome. Unfortunately, there's some problems inside of Active Record that keep us from doing that, which is why you may have noticed the weird like return unless something or other in there. But it would be very cool if we could just say, all right, straight up dump JSON on in there. But the important thing to me was that the API that I defined was consistent with the stuff that we see in standard library. I think this is important for many people's APIs, so that you don't have to think about how to use this. It already makes sense. You know how to use YAML and JSON and Marshal from the standard library, so you should know how to use this API already. I don't have to teach you anything. Another important decision for me about this particular API was that you get to choose your serialization strategy. So if you know you're on Postgres and you could store stuff in the HStore, you get to choose using the HStore, and it just works. An important lesson I learned from this was that good abstractions yield good features. So I didn't specifically go into Active Record and say, hey, I want to make sure that you can store stuff as JSON or BCrypt or whatever. I went in there and said, why are we so tightly coupled to YAML? Why is the API so hard-coded to use YAML? We should be able to configure this with whatever, because someday maybe we'll want to change off of YAML, right? And after refactoring the internals of Active Record such that I could do that, this feature fell out. So it wasn't specifically that I wanted to give the world this feature. It just happened to be that way after doing good abstractions in my code. Another important lesson for me was that consistency yields freedom and flexibility. Since we're consistent with this API, you're free to choose. You can choose any of these things that are in standard library eventually, with these small caveats. But this seemed very important to me. Now, the next thing I want to do is I want to contrast that with, I don't know if this was a controversial feature, but it kind of annoyed me. Has secure password. Has secure password, what it does is it says, all right, we declare has secure password in our model, and now our model has a password field. And it gets automatically encrypted and put into the database. So we can say, find a user, set their password. This is my password on everything, so don't use it, please. Save that off. Unfortunately, so its advantages are it introduces this new method, and it saves stuff to a column called password digest, and it uses BCrypt. BCrypt is secure, it's good, use it, please. But what I don't like about it, I feel its advantages are also its disadvantages. When you see that, you don't know that it stores it in that particular column. There's magic behind this method. It's making assumptions for you that you don't know anything about. And that kind of bothers me. The other thing that bothers me about it is I have no way to reuse it. It only works in this one particular use case. All of my applications at work can't use this because we don't store our passwords in the same column that that does. We don't necessarily use BCrypt. We might be using like SHA-256 or something crazy like that. It doesn't work for me at all. So when I see this, I just think to myself that when I'm designing API, I need to go green. I need to design something that I can reuse. When I think about API and I think about implementing stuff for other people, I think to myself, how can I reuse this? How can I reuse this in my own applications? How can I reuse this in my own code? And the problem for me with that feature is I can't. And the other kind of strange thing to me is I showed you earlier in our serialization strategies, we were able to put together something that saved our code as BCrypt or whatever we wanted to. So you might assume that the source for has secure password just uses serialization strategies. Guess what? It does not. So if you have time and would like to contribute to Rails core, I suggest that you refactor that method to use serialization strategies. I would appreciate that. So the next thing I want to talk about is streaming responses. Streaming responses is a new thing in Rails 3.1, and what we're going to be doing there is, or the idea behind streaming responses is that somebody can make a request to your web server, and you immediately get data, right? The data it's sent before it's completely done. Currently, in Rails 3.0, we process all of our ERB, buffer it up all in memory, and then spit it out to you, right? And what we want to do in Rails 3.1 is we want to make it so that it spits out data as soon as it's ready. So we process some of the ERB, spit it out, process more, keep spitting it out, so that we can be spending time processing on the server while our client is downloading data and maybe going off and fetching assets in parallel. Okay? And to understand specifically how this is implemented, we need to look at the rack API. This is a very simple rack application. You have to implement a method called call, gets an environment, and you have to return a triple. And this is very important. Please note, in later slides, I will talk about this. You have to return a triple from call. And the third thing in that triple is the body, and it has to be something that you can iterate over. Okay? So what we do in Rails 3.0x is we say, all right, append to this body, render our content, render our layout, keep appending to this body, and then return the triple from our generator, which is our application. And then that bubbles all the way up our rack middleware stack and then gets spit out to the socket. What we want to do in Rails 3.1 is we need to do delayed evaluation. We need to actually wait until until we're back up at the socket, and we need to spit stuff out before we start processing. So we want to delay that evaluation and return up the stack. How we do that is we take advantage of body.each. So we know that rack calls each on the body. So what we want to do is we want to actually start generating data inside there. So we postpone our calculations until each is called on the body. So in Rails 3.1, this is absolutely not what the source looks like. I have simplified it completely, but it's something similar to this, where we create a new object, and it does processing inside of each, and we just pass that up the stack, and our evaluation is delayed until we actually write out to the socket. But I want to talk a little bit about middleware now. There's a problem. There was a huge problem for me implementing this with actually, Jose did the hard work. I just dealt with the middleware. The problem is, middleware is a chain. So it's a linked list. We have a bunch of middleware, one points to the next, and then finally we get to an application, right? And say we have a request timer, connection manager, application. Our middleware chain is much larger. than that, but I want to keep it simple. And when we do, when a request is processed, the web server calls the tip of the linked list, and that just keeps calling down the list until finally you get to a generator, which is our application, and then we return back up from that, and that gets to the web server, and then we start spitting stuff out. So let's think about the way that the connection manager works specifically. It opens a database connection, then it delegates off to the next middleware in the chain, and it saves off the return value from that middleware that it delegated to. Then it closes off the database connection, and then it returns the values that it saved off when delegating. Now, I don't know if you've spotted the problem with this, but we have delayed evaluation until we get back up to the I/O. So when we delegate, by the time that the delegate has returned, we haven't actually done any processing. We haven't actually done anything. So then we close off the database connection and return those return values up to the web server. The web server calls each and starts processing the ERB, and we have no database connection. Then you get these exceptions, and you're like, what happened? So how do we fix this? How do we deal with this solution? And the way to deal with that is we need to take advantage of the fact that rack will call close on the body. Okay? When it's done iterating over the body, it'll actually call close on it. So what we do is we have to proxy each body that gets returned. So we implement this proxy class that points off at a delegate body, iterates over the delegate, and then finally when close is called, then we close off our database connection. So our connection manager then becomes, all right, when call gets called, we open our database connection, we delegate off to the application, we instantiate our body proxy, and then we return. We don't actually close the database connection at this point. Oh, I know you can't read this. This is our middleware stack when you do a new application. This is actually a little bit old, and we'll just go through this slowly. Oh, yeah. Look at that stack. So awesome. So I had to go through all of these objects, look at their implementations, and find things that would break because of this delayed evaluation. And for every one of those middleware objects that would break for delayed evaluation, we had to implement a body proxy. No, don't clap for this. This is terrible. This is horrible. Body proxy. I had to go through about, I don't know, 25 middlewares, probably more, and find all of these where we would break. And it really kind of annoyed me, because if you think about it, we have a bunch of filters, and then we have a generator at the end, right? But our generator isn't actually a generator. It's just returning a triple. It's returning a generator. We've turned the body is a generator now. So we have a generator that returns a generator. This seems broken to me. And I think the way that we need to fix this is we need to embrace diversity. We can't jam all of these different types of content processors into one thing called middleware. It doesn't fit. We need to look at the difference between the way these particular things process content and split them up. And if we look at it, there's really three basic things that we do. We have something that generates content, which is typically our application. And then we have filters, which actually modify the content. For example, if we have a gzip generator, we actually gzip the content before sending it out. And then we have things that deal with lifecycle handles. For example, the database connection things we were looking at. The database connection, the connection manager doesn't care what happened between the request and the response. It just wants to open the database connection when it starts. And when it's done, it just wants to close the database connection. It does not care what happened in between. All right. It's time for some real talk. Oh, this is the other part where I get to contradict Dr. Nick. Rails is getting slower. Nobody's clapping. Come on. So Rails is getting slower, and Rails is getting slower because it's doing more work. OK? I went and benchmarked Rails 2.3 versus Rails 3.0. Our x-axis is the number of requests that I performed, and the y-axis is the amount of time that I did. And for these benchmarks, I cut out the web server part, so I actually just wrote Ruby code and benchmarked our rack stack. I wanted to see how many requests per second that I could push through the system. And our growth is about linear here when we do this, but when we look at our average requests per second, we'll see that Rails 2.3 is significantly faster than Rails 3.0. And unfortunately, we're doing a bit more work. Like I described, all of these body proxies in our middleware. We're doing a little bit more work for Rails 3.1. I didn't include that on here because when I benchmarked it, it was only like, is basically exactly the same. Very close to the same, and I just thought it would clutter the graph. So I just want to compare 2.3 and 3.0. So it's not really fair to compare these two, and the reason it's not fair is because our middleware increased. We're actually doing more work in our middleware than we were doing. We're doing more work in our middleware in Rails 3.0 than we were doing in Rails 2.3. Okay? But the thing that bothers me is when you go and profile that and look at all the middleware in our stack, none of it actually seems to be taking up very much time. Right? We're doing more work, but none of it is really time-consuming. So where is this time going? It's going to our garbage collector. We're putting a lot of GC pressure on Ruby. And I guess this is the part where I have to say maybe you should use Rubinius or JRuby or something like that, or REE. But the reason we're putting pressure on our GC is because of stack depth. Every release of Rails is increasing its stack. And the way that Ruby's garbage collector works is it has to scan the stack for objects to collect. So obviously, as our stack gets larger, the garbage collector has to do more work. So maybe it would behoove us to decrease that. Our Rails 2.3 stack was 51 deep. And this is measuring from inside of your controller. If you just say puts caller, you'll see that it's 51 deep. In Rails 3.0, it's 60 deep. In Rails 3.1, it's going to be 67 deep. So if you look at the caller from your controller, say puts caller, it looks like this. I know it's way too long to read, which is why we have a stack trace scrubber. So how do we take care of this? How do we fix this? This is something that needs to be fixed, I think. And ironically, the way to fix this is the same way we need to deal with those body proxies, is we need to embrace diversity. We need a change. We need to change the rack API. We need something that's not dependent on return values. You notice earlier, I made a point saying when you call, it has to return something. We need something more evented, something that supports streaming easier. And the API that I am proposing is something that looks like this. We split up generators, and we actually write a response out to something. And then we close that response when we're done. The next thing we need to do is we need to implement filters. And these filters are specifically for filtering data. They can buffer stuff up, or they can gzip things. They can do whatever they want to, but their only responsibility in life is dealing with response data. We need to also support lifecycle hooks so that we can support things like the connection pool, where we bring up a connection and then tear it down at the end. Now, I put together a test implementation of this with no web server front ends, like it won't work with Unicorn, and I ported most of our rack stack to this to see what the performance differences would be. I brought the stack depth down to about 36. I did my profiling here to make sure that our request and response was still a linear growth, so I didn't screw anything up. And our requests and responses, I was able to push through more requests per second on Rails than 2.3 could, and that's doing the same amount of work that we do in 3.0. So if we decrease the stack size, we'll be able to do the same amount of work in less time than Rails 2.3 can. So I think that this is a very important thing we need to do. This graph is an estimate, but I believe it's conservative. Okay? So something very important to me in the coming year is that we must change. We need to change this. And the things that I want to be focusing on in Rails for the next year are speed, memory consumption, stack depth, but most importantly, I want to make sure that it's backwards compatible. Thank you. So finally, the last thing I want to do is I was having a really hard time figuring out all these problems, doing all these benchmarks, figuring out where all of our time was spent, and I consulted many people to figure out what the problems were, and I learned developer pro tips from these people, and I would like to invite them up on stage with me here. And I want them to show you all these pro tips. So this is, all right, this is what you do to become a professional Ruby developer and to find bugs like these and to fix them, all right? They all said the same thing to me when I went and consulted them about these particular problems. And so I just want to share with you what they told me to do. Ah, there you are. Right there, perfect. Oh, actually, before we begin, you guys, what the hell? 4 people from Ruby Core signed up to do the 5K. Only I showed up. Or Rails Core, excuse me. What? Come on, guys. What the hell? All right. So anyway, developer pro tips. Let's do this. Oh, I'm sorry. Wayne. Will you change, please? Wayne has to get into his dancing gear for us. Actually, this is specifically what Wayne said to me when I asked him about these problems. Over I am, and it was just that loud, too. All right. So, are you all ready for this?
Start with your heads down.
Everybody.
Now look up slowly. Bring your arms up and bring them down. They're going to go up again, both arms, higher this time. Turn them down. Bring your thumbs to yourself and down. Point your right hand from low to high. Burst your right hand. Now fists to your sides.
9, 8, 7.
Now your fingers, 5, 4,
3, 2, 1.
burst both hands. Up, punch, across. Crank, crank, stay down. Shoulder, chin, shoulder, and pat. Double dream hands, and thumbs to yourself. Punch again. Now point your right hand from low to high. Punch, crank underhanded. 2 pats, shoulder, double dream hands. Up, just like before. Crank. Stay down. Shoulder, chin, shoulder, shoulder, shoulder. Double dream hands. Again. Thumbs to yourself. Punch. Punch from high to low. Punch. And crank underhanded. Pat twice. Double dream hands. Again. Up. Rock out now. Crank it. Stay down. Shoulder. Chin. Shoulder. And double dream hands. Now, jazz hand. Up. Right hand. Rain hands. Point your hand over there. Step clap. Jazz hand. Burst. Again, left jazz hand. Clap. Clap. Pants your knees. 2-step claps. Reach to the audience. 2-step claps. Hands to your knees. Left jazz hand. Left. Right. Burst. Like before. And point high to low. Crank your underhanded. Pat. Double dream hands. And butterfly. Double dream hands. Freestyle. Make a tight group. Punch.
You did. You came. Thanks, guys. Thank you. Thank you. Thank you. Thanks. Thank you. Thank you, guys.
Want a group pose?
Actually, should we have a pose? Yes, I have 2 freaking minutes. Get back up here on stage. So my real difference between all the other keynote speakers is I can get some of the most important Ruby people in the world to come up on stage and look like idiots. Everybody, get together. Come on in. Come here. Come here. Come here. We're posing for pictures now. Thank you, everybody. Wait, what?
I'm a poser.
All right, thank you. I have 90 seconds left. Oh, thank you. Thank you, guys. Thank you all. I feel amazing now. The embarrassment or the stage fright is completely gone. So I want to leave you with some final words. I want to leave a message. I want to start with a message for the rest of the Rails core team and for the audience. I'm kind of out of breath now. 5K plus dancing. And none of my Rails core team teammates showed up. So the Rails core team that you know today may not be here tomorrow. Right? Wah, wah. DHH isn't necessarily going to be around developing on Rails for the rest of his life, but I firmly believe that the Rails framework will be around. And I think it's important for us to make sure that we refactor the internals of it so that we can get new people in and new people developing on core Rails itself. We need to get more people into the Rails core team, more people helping out with our beloved framework. The last things I want to say are not all features are tangible. Speed, memory, I/O. Good abstraction yields reusable code. Reusable code yields new features. So your homework from now for the rest of your life, go green, write reusable code, refactor Rails, and go forth and code. Thank you.